So welcome to the fifth in the battery supply chain meetings that we've been organising on behalf of the Chemistry Council, and increasingly, and you'll see it exemplified today with the full engagement of everybody from the Auto Council, APC, Faraday, and everything. We're more joined up in this area than almost anything else that's going on at the UK at the moment. So welcome. Today, as with all these meetings, is a response to people asking in the past what's going on, how could tell us what's going on. The first speaker today is Tony Harper, who many of you know is really key in this whole area. He's been in it for many, many, many years now. And he's going to be talking about what's happening at Faraday and the UKRI and how it's all the funding and the development of ideas and the coordination of people is going to happen over the next couple of years. And that's really important because, there's a real need to engage with the chemistry community, which is why we're having these meetings. So, Tony's a great talker. Next, we have Jennifer Chanel, who is new to this community, but she's going to be talking about the skills programs that are being developed and implemented. It's really quite important that we get the reskilling that's necessary for the people in particularly in the sort of the chemical and engineering conventional attitudes, so that we can understand what's going on in this new area of batteries and electric motors and so on, and power electronics. So that's really important. And then last but by no means least is Jackie Murray, who again you've heard of before if you've been with the community. And it's going to be talking about standards. Standards are an interesting area because, and I think she's captured it nicely in the title of the thing. This area is moving so fast that standards are having a good try at keeping up, but not always making it. So those are the three talks, and then as is standard with these meetings, after those. We'll break out into 3 syndicate sessions where we'll talk about what we've learned today, clarify any problems or misunderstandings we might have snuck in by mistake, but also ask you again what you want to know more about, because as I said, these 3 areas came out of people in the last 2 meetings asking about them. So that's what's going on this morning. So this is me before lockdown when I actually looked human. This is I look more like the actual moving picture these days. And I'd like to thank, as always, Abel and Imri. They're the sponsor of this series, which makes it easier to bring it to you and things like that. So and the involvement of patent attorneys, trademark people, and everything in these sorts of fields is really important to maintain the commercial independence and control the markets, things like that. So thank you, as always, to them. I don't know whether Jim's here yet, but so the 3 speakers today, Tony Harper, as I said, Jennifer and Jackie, and I'd like to now first hand over to Tony.
So good morning, everyone. It's a great pleasure to be here to talk to you this morning. David asked me to come along and talk about 2 general questions, really. What needs to happen next? This is obviously in the context of batteries, and where might funding be applied? And I'm going to answer those questions in the context of automotive, because as always, it's the largest sector, and it's the one that's driving the timing and the technology at the moment. But I will talk about other sectors as well. So first slide is actually a slide of UK vehicle production. Now, obviously, it's been hit by COVID. So prior to the pandemic, we're making around 1.8 million vehicles. These are cars and vans in the UK. Has been reported widely in the news that plus the chip shortage, actually, the silicon chip shortage, has hit production over the last couple of years, and we're currently sitting just slightly around the 1 million units mark. So that is a very dramatic reduction. And you can see there's a few projections about how that will recover. And this relates to some analysis work that I'm going to take on to the results of in terms of what that means for the electrification journey and the degree to which it affects our view of battery assembly and supply chain that we need in the UK. So the orange line is a hypothesis about how that recovers over the next few years. There are debates about whether that is correct or not. So that's one piece of data. The other piece of data, though, which has changed dramatically in the last couple of years, is the forecast around the degree of electrification within that volume. So a couple of years ago, we had most of it was being driven by the European CO2 tailpipe standards and the need to get to zero emissions for some of your fleets to hit those standards. And there are various projections out to 2040, 2050 that showed some degree of electrification. But the thing that's really changed in the last couple of years are certainly the UK's announcement around the cessation of the sales of internal combustion engine only, new internal combustion engine only vehicles in 2030, and then anything that isn't zero emissions at the tailpipe from 2035. And although perhaps not enacted in legislation yet, it looks as if Europe and many other parts of the world are going to enact very, very similar regulations. And therefore, the projections about the degree of electrification, as you can see on this chart, which relates to UK production, shows that by 2035, some 80% will be battery electric. And in fact, we'll be making more battery electric vehicles in 2035 than we are making vehicles of any description today. And that's even with with COVID. So some work has been done within the Automotive Council to look at what that means in terms of battery requirements for the batteries to the factory gates, if you like, in automotive in the UK. There was a previous study done by the Faraday Institution, which was an update to a study before that as well, that many of you might be familiar with and might have seen, that sort of plots the gigawatt hours per annum that's required to feed the UK automotive industry. That this is the blue line, is the pre-COVID line, and intriguingly, the crosses on here are the latest study, the post-COVID line. And what that means is that the degree of electrification or the acceleration of electrification of our factories, or the cars that are making our factories, is outpacing the drop-off of production due to COVID. So not only are the previous predictions around the number of gigafactories, etc., that we will need true, they're actually now conservative, and it's really because of the UK and indeed Europe and elsewhere in the world, making it very, very clear around the end of sales of the current technology. Okay, so what needs to happen? So from an automotive point of view, there's obviously quite a lot of work going on this, and the government specifically commissioned the Automotive Council to come back with, right, we are going to enact this legislation. This is what's going to happen. However, what did we recognise that things need to happen in order to facilitate that fundamentally in automotive? What does that mean? And it means we've condensed that into four main things that need to happen. So one is to support the OEM with platform transition activities. Now that might sound a little bit obscure, but what it means is that every car company that operates in the UK, be it Jaguar, Land Rover, Nissan, Toyota, will have all had plans around their vehicle platforms, as they're known, that support the products that you see in the showrooms. That those have an investment life and a manufacturing life. Some of them will have been heading towards electrification anyway, particularly those ones that were being renewed around about the time of the announcements. But there would have been others that have had investment in them that they expected to last beyond 2035 or 2030 at least. So what happens is if you not arbitrarily, but if you say you cannot sell certain vehicles past a certain point, you have to reconfigure the refresh cycle of all of your vehicles, There's major multi-billion pound investment that goes along with that, and essentially it's created a huge investment gap before 2035 that wasn't there before. Yeah, and that needs both financial and technological support if that's going to happen. We need to embed the EV supply chain into the UK for all sorts of reasons. There's some regulatory type reasons. So there are rules of origin now around the value of vehicles and also of batteries that is allowed to be, well, not allowed, but can be made outside of the UK or the EU without attracting tariffs in the future. That's all part of the Trading Cooperation Agreement between the UK and the EU after the UK's exit from the EU. That financially strongly incentivizes manufacture either in the UK or the EU for batteries. And clearly the UK has a very strong incentive to get its share or more than its fair share of embedding that supply chain into the UK. As well as, and that's an expensive business as well, and no doubt we'll explore that. We also know that we are just, from a technological point of view, we are just at the beginning of this journey. So where we are with battery electric vehicles now is roughly where the industry was with the Model T and the internal combustion engine almost 100 years ago. There are enormous gains that need to be made to make the EVs as accessible, as high performance, as usable, and as cost effective as the people, as all of the population in the country needs. And there's a massive amount of work and innovation that needs to be done there. And then we also need to recognise that although once you shift light cars and vans from their current technology to electrification, you get an immediate drop in CO2 emissions, even on taken on a whole life basis, around 40–45% drop. However, it is far from zero, and clearly we've got to hit net zero by 2050. You don't just do that by banning the sales and transitioning and saying the job's done. There are all sorts of process steps and energy steps in the supply chain, etc., that have to be decarbonized to get to true net zero. So those are the four things that need to happen fundamentally in automotive. Not much different actually in aerospace and some of the other sectors as well. Heavy goods vehicles in particular seem to be following at about a 5 year, 5 years after automotive, but same drivers, same requirements. So as David was saying, in the UK over a number of years, actually, we've built up a support ecosystem, which is, it is highly coordinated and you know, unusually so, actually. Not only unusually in terms of historic and other industry comparisons within the UK, but actually globally, it's a pretty exemplar joined up support system that we have now in the UK and that we intend to develop going forward. So someone like myself and the colleagues that are also presenting this morning are involved in the Faraday Battery Challenge, which coordinates all of the scientific research, the mid-TRL development, and the scale up of not only batteries but materials as well. That's a joined up support program within UK research and innovation, and it isn't just about the technology. It's also about making sure that we're continuously doing the right thing, that we're building communities. And Jennifer also is going to talk about the skills program later, and embedded in there is also our work on standards that Jackie will talk about. But we long recognise actually that just even having joined up research and innovation activity, which is unusual in itself, is not enough. We need to link that up with the support system and the perspective of industrialization. So major capital investment that's required to fix some of the market failures that are associated with the pace that we talked about, or that David talked about earlier, and also that we need late stage application R&D programs. This is all about batteries, but also you need late stage R&D programs to fix some of those things I talked about earlier across all of the sectors. So that's the picture. As I said, this has evolved over 10 years. It's got to a good point. I think it will be further enhanced actually with some specific OEM support, particularly on that transition of the platforms that I talked about earlier. And it makes for a pretty world-class joined up ecosystem. So if we look at each one of these elements, so the support for the OEM platform activities, that's mainly provided by the late stage R&D program support, and in the car world, it's the Automotive Transformation Fund. Both of those are run by our colleagues at the Advanced Propulsion Center, but there are similar activities that are supported in aerospace by the ATI, for example. But the business of shifting platforms from their current technology to new technology isn't really a research activity. It's not even a mid-TRL activity. It's an urgent late stage R&D and industrialization activity, and is supported mainly by those two interventions. If we move on to embedding the supply chain into the UK, it's everything actually. So we are highly involved with many of the chemical companies on the call here. There are, you only need to read the press to see some of the activity that's going on in the support for the industrialization of the supply chain in the UK, and there are also again late stage R&D support that helps embed this as well. But obviously this is a very key one to our conversation here. We know that if we just do modules and packs and import cells from overseas, we only capture about 15% of the value. If we make the cells here but nothing upstream here, we capture about 45% of the value, but we capture 80% of the value if we include if we embed the supply chain. So it's absolutely critical, and because of the urgency that we've all talked about, we can't just start researching now and developing and hoping it's all nice in the future. We have to support industrialization now, and that's what many of these programs are about. As I said, it's an ongoing the business of innovation, performance improvement, cost reduction, etc. is going to be the business of many years, and that's why we have the Faraday Battery Challenge, but also the late stage R&D activity and the application integration activity supported, and innovation to net zero again. So we have significant research development and scale up activity on recycling, but not just recycling. We also need to concentrate on reducing the energy use of what is a fairly energy intensive supply chain. So all of these programs are in place now. Obviously we are coming up to the Faraday Battery Challenge is coming to the end of its first phase at the moment, and we are actively clearly defining what the next phase of the Faraday Battery Challenge is. There's also work going on the next phase of ATI and APC and the Automotive Transformation Fund, etc. So we are at a slight transition point at the moment, going from a few years now of creating and embedding these programs, but we need to grow them and consolidate them going forward. However, all of that right now is clearly subject to the spending review and various bids that are occurring. So the Faraday Battery Challenge Phase 2 proposal as it is at the moment, in a little bit more detail. So we intend to continue to invest in large-scale managed program of multidisciplinary, multi-institutional application-led research through the Faraday Institution. That's been for me has been a pretty breakthrough initiative since it was started. And for the first time, we're really marshalling all of the scientific strength that we have in the UK, but coordinating it and targeting it. And many of you will have seen already, after what is effectively 3 years, we've got a major MOU between some big companies that are on this call as well, that are taking the first steps to exploiting the outcomes of the solid state program, which is just one of 10 programs in that area. We intend to continue with the mid-TRL development, but expand the interventions so that they cover investor partnerships. So collaborative research and development programs, which we've mainly deployed in this area, are good. They bring together big companies, small companies, universities in scaling technology type programs. But sometimes you just need to support the long years of R&D to bring some of this technology to market in single company interventions, and you need to help, and you need to de-risk that with some public money, and that's what that intervention about. That's going to be new to us. Jennifer's going to talk about the dedicated budget for skills. It's a huge issue, and then perhaps interestingly for some on the call, we recognise that there are still some gaps in the infrastructure in the UK to support development and late stage development. So we've got the Battery Industrialisation Centre, which has obviously been the major intervention so far from Faraday in this area, but that doesn't stand still. That needs to be upgraded. We need to upgrade the Energy Innovation Centre, which is the activity at Warwick University that was actually commissioned and built, towards the beginning of the last decade. So that needs to be upgraded for current chemistries, but have its output matched to the capability of UK BIC's input, which is obviously clearly changed. We need a similar capability as for the EIC, but for new chemistries. And we also working with many people in the chemicals community have defined the need for a pilot scale materials scale up facility, particularly for next generation chemistry. So all of this is subject to to the spending review, etc., etc. But in terms of answering the question, where do we intend to go next? Hopefully that shines a bit of light in that subject. Thank you for your attention, and look forward to discussing it later.
Okay, thank you very much, Tony. It is monstrous to see how much it's evolved over the 15 or so years we've been working together. And so, I mean, it's really nice to see that coordination you started to build in all those years ago is paying off. So it's brilliant way of kicking us off. So there's lots to go at. In particular, you'll note the EIC and the UK BIC were always on the plan. We have to do them, but now we've got the precursor work that has to go on is in the program. So that's about this community. Brilliant. Thanks a lot, Tony. So, but Tony pointed out that we've got to do the skills, and it's been following behind a bit, but we now have the beginnings of an integrated things. There's been lots of stuff around episodically, but now we're going to hear about the overarching plan for world domination from Jennifer, I hope.
Thanks, David. Hopefully you can see that. So thanks for inviting me to speak today. My name's Jennifer Channel, and I lead the skills workstream for the Faraday Battery Challenge. And today I'm here to talk to you about the opportunity for a national electrification skills framework and forum. So as has kind of been discussed, the skills element is really important to enabling the UK to realise its ambitions around electrification. So together with the industrial digitalisation and industry 4.0 revolutions, the electrification one represents also the largest shift in industrial skills for the UK in a generation. And the need to move both quickly and effectively to reskill and upskill the existing workforce, whilst also providing newly skilled workers to fill crucial roles, really emphasises the need for a national skills structure more than ever before. So to address this, we're proposing to introduce a national electrification skills framework and forum, which is based on the principles of a national effort. So it really should be joined up across the UK. It should be based on quality, so the quality of the training provided should be embedded within the framework. It's based on both the immediate and future skills needs of industry. And it's based on reskilling and upskilling the current workforce, whilst also introducing new skills into the workforce too. And then finally, I think this is the most important point, it's based on collaboration, and it's really through collaboration that the framework and forum idea has really come to pass. Who should engage? A wide range of people. So employers should engage with this. They need to reflect on existing and future skills needs in a structured way. And this should also ensure that the training and skills needs are provided in a timely and effective way. Training providers should engage with this. We need them to engage with industry on a national scale to participate in this combined effort. We need accrediting organisations to engage. They should engage with wider employer groups to better understand the needs and reflect these more widely in accreditation. And then, of course, the learner at the centre of all of this should engage, and they should be able to access opportunities to develop those transferable skills through a really flexible learning route that meets the national agenda. And there's a wide range of benefits of being part of this. Amongst these include seeking close engagement with national and regional stakeholders, reaching across a growing network of further and higher education and training institutions and providers, taking advantage of increasing online learning content. And I think we've really seen that increase massively over the duration of the pandemic. And this is aligned to experiential learning and assessment within the overall framework. We want to ensure that businesses of all sizes are able to access a skilled workforce to enable them to meet their business needs and compete in growing markets. And we also want to provide individuals with initial and lifelong learning opportunities that will enable them to secure future work opportunities in expanding green industries. So the framework itself is based on the following approach. So it crosses skills levels from 2 to 8 or equivalents of this. It's informed by industry partners from a wide range of sectors, but it's also sector agnostic. So electrification is being considered as a whole rather than a separate industry sectors. It's based on common but also less common curriculum. So it's making use of cross-cutting electrification themes that are the same regardless of the sector or the role, to ensure that it's being consistent but also efficient in its design. And then sector-specific elements are added as required. It's modular, so long course programs are deconstructed into short modules, and this allows employers to select the aspects that are relevant to them to allow for upskilling and reskilling of the current workforce where full programs aren't required. It's current, so incremental changes to the short course programs can be readily reflected into long course programs. It's also consistent, so the content, competencies and assessments are the same regardless of the mode of the delivery. It allows credit accumulation, so individuals will be able to accumulate credit from across the courses and bank these against larger qualifications. There are no dead ends, so individuals will always have the opportunity to further their careers through training and education, and progression routes will be clearly articulated and made available to them. And it should also widen participation, so there'll be multiple entry points and opportunities, which will help learners to engage more widely through an inclusive and accessible route to education and careers in electrification. And it's really based on the following strands to help meet industry needs, so around STEM and STEM outreach, long courses, short courses, credit accumulation and accreditation. So the forum part of the framework is really a call to action and to bring together people to collaborate around the common need to develop skills in the electrification workforce. There's 2 networks that are embedded in this. So there's the provider network, which aims to convene providers on a level playing field to share resources to ensure the highest quality of training provision. And this network co-develops curriculum whilst members support one another to develop and deliver against the framework. And then there's the employer network, which stimulates cross-sector collaboration and learning, which will enable employers from a wide range of industries to establish common skills needs. And this works hand in hand with the provider network to ensure that skills needs are communicated and that courses meet the need. So these networks are growing and there's opportunities for you to get involved. So if you're interested, please do contact us. So the genesis of the framework really came about through thinking about the need to integrate workforce development with technology development. In the Faraday Battery Challenge, we see part of our role is in securing the UK's battery manufacturing industry. And so as a part of that, we absolutely have to have a role in ensuring that we're resourcing that industry and providing the skilled individuals who can meet the UK's ambitions. So at the moment, the framework is currently based around vehicle electrification, battery manufacturing, and power electronics and drives, working with Driving the Electric Revolution programme, the Industrial Strategy Challenge programme as well. And it started with automotive, but then we realised that there's a real opportunity and a need to expand this into other sectors. So looking at aerospace, rail, marine, energy, and others as well. The methodology for this is based around the skills value chain framework that was published in the Manufacturing the Future Workforce report that the High Value Manufacturing Catapult worked on with the Gatsby Foundation. And this is based around establishing the needs for skills, so foresighting future workforce capability, and then defining roles, occupations, and standards. Then creating resources to meet these needs, so developing modular curriculum content and setting up assurance, validation, and recognition, and then delivering and diffusing this, so training the trainers and then scaling this up with operating providers. And the workforce foresighting process really consists of capturing industry challenges, determining what the organisation capability changes are going to be as a result of the change in the technology, defining the future workforce competencies based on this, and proposing what the future workforce duties and roles would look like, and then prioritising and articulating gaps compared to the current state. So what is the current training provision that's able to meet these needs, and where are the gaps in that training provision? So in the skills framework, there's been development of modular CPD units. So the first step of this is assessing industry capabilities. So UK vehicle electrification design and manufacturing strategies, roadmaps and plans were assessed by technical experts to identify future capabilities which are required by UK manufacturing. And this is to enable their adoption of battery-powered automotive solutions. Workforce competencies were defined, so expert educators defined the appropriate competency sets for 3 role groups: technical operator, junior engineer, and senior engineer. And knowledge and skill competencies were developed, and this was linked to specific capability requirements for each role group, which were then used to inform future reviews of apprenticeship standards and qualifications. You then curated existing CPD course provision, so mapped what the current state was, understanding what current training provision could provide the competencies needed, and then identified further courses to create. And so where there's no current suitable continuing professional development offer, the Department for Education funded Emerging Skills Project, which is being led by the High Value Manufacturing, is aiming to create pilot courses and train the trainer content available for rollout in 2022. And this is working with the Warwick Manufacturing Group and the Institutes of Technology. So for the battery manufacturing framework, this is an example of what it looks like. So on the left-hand side, you've got example roles for battery manufacturing, and then you've got examples of apprenticeship standards and long courses which could meet the needs of these roles. And then on the far right, you've got examples of short course programs which could be integrated into these courses to meet the gap in training provision. So far we've had participation from over 75 organisations, and this list continues to grow across the 3 different areas that we're currently working in, which is the vehicle electrification, battery manufacturing, and power electronics, machines and drives. So the next steps are that the framework report will be published and launched later in September. At the moment, we're working to secure funding and collaboration to continue to support this work and build in other technology areas and sectors into this framework. So, for example, the upstream battery manufacturing supply chain, electrification through use of hydrogen fuel cells, that sort of thing, and expanding this into other sectors as well. So for more information or to get involved, please contact the address below, and thank you for your time.
Thank you very much, Jennifer. That was excellent. And for those of you who were desperately trying to write notes, don't forget that we can provide the slides, and the meeting is being videoed and will be available on the SCI YouTube channel, hopefully mid next week, because there's a lot in there. It's a very thorough program, and you'd be surprised how many people get quite a way down trying to do something before realizing their people need more skills and such. So it's really important that you pay attention to the fact that this is available, it's coordinated, the quality is effectively guaranteed because it's a national program. Really nice piece of work, Jennifer. Thank you very much. So the last speaker today is Jackie Murray, who is also, of course, part of Faraday, because they are the center of things at the moment. And it's about standards. Now, we had requests, as I said, about what this means. And there's been a process that Faraday been working with BSI and things like that. But it's really important that if you're making something, you know that it fits in with all the other things and that sort of thing. And we've seen standards cause real problems in different fast-moving areas. VHS Betamax is the famous one. So it's really important. So welcome, Jackie, and thank you for talking.
Thanks, guys. I have got dropped into this a little bit late, so I've got some slides in here that perhaps you don't really need following Tony and Jen, but I'll flick through them just because that's always useful to sort of just check sort of understanding. So the question is, when we are working in something such as battery innovation at the speed that it's evolving, how can standards actually help? Because there's from the start, there's been a real reticence, a real worry from people and stakeholders for Faraday that actually standardization would really constrain and cause problems. Now, my background steelworks, where I used to be a manufacturing engineer. I used to run labs as well as on plants, so used to automotive standard audits and internal audits and all those other sort of pieces and all the standards that went along with it. And then went to work for the Environment Agency, who obviously is a regulator, so then got into the regulatory side of it and the standards that underpin a lot of environmental permitting, for example. So that's my background. Coming in here and looking at Faraday, it was a question of what is it these guys need to do? So these are the slides you probably don't really need, but I'll just touch on them because I think they're really useful. This is really the net zero from the government. This is the plan to get to net zero by 2050. And you can see again that, you know, you've got cars and vans being the main contributor. And we're looking at actually how you can, how the UK can really play in this space. How can we be on the front foot? How can we know what's coming? And the answer for me really is this, I think Faraday was one of the more surprising policies. And I know Tony fought hard for it to actually come about, but actually making the step into battery technology means that actually we have far more of the knowledge to be ready for what actually the long-term future of transport and propulsion systems really are. And it's based very much on UK's manufacturing and the fact we manufacture cars, and as Tony talked, it's dropped, but also that I guess as a motorsport fan, we're very good at making engines, we're very good at making things go fast, we're very good at integrating those propulsion systems so that actually cars, vans, they feel great to drive and they deliver efficient sort of transport back to us. So it's a useful thing for the UK. This piece of work hasn't actually been published yet, but it will be shortly. And this is really showing you that even small, medium and large, a full electric vehicle might cost you more in terms of carbon emissions to manufacture, but very quickly, even when you include recycling, you can see that the life cycle, the usage phase compared to an internal combustion engine gives you about a third, perhaps a bit less, of the CO2 emissions. And that's right now. And the point here is with your help, with the supply chain sort of coming around, with all the work we'll do in manufacturing terms, those numbers are expected to reduce, and by 2050 we may well see a footprint from battery electric vehicles being somewhere near a tenth of an internal combustion engine equivalent. And that's really where we got to. We got to a point where I guess we could see the bottom of, or the top of the S-curve in terms of the technology developments for internal combustion engines and emissions, and this need to make the step, or the leap, I guess, to full electric really has come about. Faraday, for those who don't know, is a three-pillared sort of funding mechanism, well, two funding pillars, and then something called the UK Battery Industrialisation Centre, which is really the prototyping facility. So if I just break that down, you've got the Faraday Institution. You're always welcome to go and check out their website. They also have a list of publications that will be really useful for you if you're trying to do a little bit of background research into some of the elements that we're talking about and you guys are interested in. And that's £110 million worth of funding into, at the moment, 10 major multi-institution programs, as well as some smaller sprint programs. And you're looking at around 22 different universities. What's really interesting is also that they're partnered into industry. And really what they're doing is looking at how research can answer the questions that industry and engineering needs them to answer, rather than doing pure blue sky research. So this is much more application-led science. Then you've got the collaborative R&D. I assume actually most people on the call will be familiar with Innovate UK and the CR&D collaborative competitions. And again, we're currently, actually, this is out of date, I think. I think we're around 160 something organisations funded. Tony will probably jump in and tell me what the answer is. But anyway, what we've got is we know we've committed around 90 million to collaborative R&D. And the piece of the puzzle that is the Battery Industrialisation Centre is, if you're in the chemicals industry, you'll completely understand batteries are very much continuous process. There's batch elements to it, but actually on the whole, it's very much continuous process with almost atomic level control on the sort of materials and the application and drying and processing. And it's really interesting to me, coming from a galvanized steel sort of background, just how similar a lot of the manufacturing processes actually really are, apart from that level of control. And what that means is running trials of the next iteration of technologies or chemistries through really is not attractive if you're a full gigafactory producer. So actually having a space where you have a fully flexible industrialization centre is a really key element in the UK strategy. It's really exciting to people who are looking at gigafactories in the UK, for example, like British Volt and others, always in conversation, looking at actually how they could train, trial, bring through technologies faster using the industrialization centre. The real beauty, I guess, in Faraday, though, and this is what I wanted to talk to you about, is really about knowledge, about UK knowledge. The reason we're good at propulsion systems is because we actually have lots of people who talk about propulsion systems in the UK, and that power of collaboration really starts to pull innovation through faster. And it's through that build of knowledge. We do it as engineers. The more I feel like I know an area, the more likely I'm going to feel I understand the risks, and therefore I'll make decisions earlier rather than putting it off. We're having a conversation we started about, why didn't we just wait for solid state? And the answer is, if we waited for solid state to become the technology of the moment, we wouldn't know enough about how that had evolved to be a player in solid state. So the ability to sort of lead in this space has become really important. And we see that through everything. You're welcome to join the Battery Innovation Network if you haven't already. I can send you the link, or Thomas might be able to put it into the chat, because I think he's in the room. Do sign up, do go and see who's working on batteries in the UK. I think there's about 450 organisations and companies already signed up there. We are working behind the scenes. I was actually yabbering away on my phone with Environment Agency colleagues before I started, really looking at joining up government, sort of the way government departments work together to ensure sustainability, to ensure a level playing field as we innovate, but also to make sure that future direction doesn't create problems that so many people are worried about. And I'm sure if you talk about batteries and battery electric vehicles, very quickly people bring up critical metal supply, artisan mining in Democratic Republic of Congo, and the need to recycle. So understanding how to manage that and regulate that, and also drive better performance is really key, particularly because actually a lot of the car companies in particular recognise their consumers are really scrutinising these products in battery electric vehicles. So there's a mutual gain from doing this. We look, and I'll talk a bit more about working with BSI, but we're actually also working with green investors. It's really around demystifying all this technology, all this stuff that you guys are also trying to demystify, but through your lens, but also for investors. And then Jen's already just talked about skills. Tony's put this in, and I guess you've sort of seen the slide, but for me, as we took this mission on, these elements of policy and regulation and standards really popped out. I guess partly because of my background, but it's actually the knowledge on how you can bring forward and inform good regulation and good standards was really key. And I always used to use this when I was doing audits on environmental systems, actually on plant, because we're so attuned in industry to a continuous improvement approach, absolutely. And what you really want are your standards, your audits, to just make sure that actually you are going up that slope of continuous improvement. And really what they do is if we have some standards, if we have some way of understanding what that slope looks like, you can take some of the risk out of battery manufacturing. And the reason this came about right at the beginning was very much setting up UK BIC and actually taking it through its permitting and planning processes, but permitting in particular, looking actually how you could demonstrate that you were operating to a high standard, that you'd thought of all the elements. And actually that's where we started to go, we need to actually really work much more openly and much more collaboratively. And I just like this description because we tend to think about going to events and social networks, and I don't mean that in terms of Twitter. You can do Twitter, but include it in there. But actually, going to conferences, going to events, going to LCV, whatever it might be, to talk to people and think about the greater picture and the future of technology when you go to sort of those sorts of things. And then going back to the office and working really hard with people you know really well, you understand their competence and their ability, and it's sort of much more hierarchical, but you know exactly what you're going to do in there, whereas you go to those events and it's much more vague and open and imaginative. And actually the real piece for me is the bit in the middle. This is where government and hopefully Faraday Battery Challenge really helps to do that, because what we're trying to do is really bring forward communities of practice that flow between those two things, right? So it's lovely to have the big thinkers and the big picture guys, but actually in those communities of practice, when you get practitioners into that space alongside, people like me, we need to do something great and transformative and all those things, the practitioners really start to pull forward detail that you need. And what that means is we start to get a much faster way of understanding complexity, and where we don't all know the answers, we've got much more idea of where those answers can be found and how reliable data and information can be. And that's one of the reasons why the PASs, for example, and the collaborative R&D really do provide us a really useful advantage in the UK. But you can go and download them. I was here, I'm actually the B team, because whilst I sponsored these and was involved in them, the practitioners that led them were actually Professor Emma Kendrick on electrode and cell components. She used to work for Sharp, so she's from industry, and you're welcome to go and download the work that's been done on electrode and cell components. I think that would be of great interest to you guys. It's free to download, obviously. There's also pack and module design, which was done by James Gady, who now sits in the Faraday Institution. He did that just before he actually moved to the Faraday Institution. But again, he apologises for not being here today. But there are technical authors you can go and talk to. And actually for vehicle design, there's also Dave, my brain's gone, but I'll come back to me. But get in touch, I can put you in touch with all of those authors. Dave Walker, thank you, brain, he's really looked at how the vehicle can be designed efficiently and safely and environmentally well. And so again, what you've got is 2 codes of practice and a design guide. So 1 and 2 are codes of practice, and 3 is a design guide. When you go through them, if you're from anything to do with manufacturing, it'll start to feel very familiar as you see COSH and COMA and environmental permitting and all the health and safety regulations that are familiar to you. It's a useful way of actually just going and looking at what you're doing and what you might need to consider moving forward. And get involved. So Tony sort of explained to you where we are. We do intend to do more of this moving forward, because actually those codes of practice really aren't locking in standards. They may be pre-formal standards, but they really at the moment are really trying to pull together those practitioners to bring that that central sort of knowledge growth, that speed of growth forward. So please do get in touch. You can see we even have a BSI email address. So definitely want your feedback. And there are masterclasses that you can also access potentially through that email address. But just do it fast, because I think they're pretty much sold out at the moment, and that they've had fantastic response from industry. And I think that's it, David. I just sort of left with this one. Maybe it's because I'm more of an engineer. Hopefully, even now, sort of 18 years into the civil service and public sector, but actually, we want that simplicity. We always want that simplicity, but we have to really understand the problem before we move forward, and hopefully that's some reassurance for you.
Thanks a lot, Jackie. And just echoes that the last couple of slides about is if you don't get involved in the setting of standards, they may actually not be the ones you really want when you come around to it. It's one of those things. I spent years in industry, and people go, "Oh, we shouldn't send people to these committees. It's a waste of time." It isn't. You actually have a say in things. They turn out the right way, and I think it's really important. Once again, the Faraday is coordinating something in an area that is of benefit to a whole bunch of people.
That's a really good point, David, right? And one thing I've learned coming from somebody who used to get involved with things like breath notes, if you know your environmental permitting, you'll understand with Europe and designing all that guidance. In this case, the pace of change in batteries is faster than regulatory process. Or even those committees that David's talking about, they will move slower than the technology is moving now. So the upside of this is giving a real touch point for practitioners in the UK. And actually that information from those will also feed into those wider committees. And then what we'll really be keen is to have British companies participating in those ISO and EU standards, and have something that's very much an offer. So you're not just going in as you've had some engagement with a much wider community in the UK. We have to do something different in this case for batteries.
Excellent. Well, so thank you, Jackie, particularly because we did drop you in at the last moment when BSI lost some emails. And Tony and Jennifer, as always, brilliant things. Hopefully you've all learned something new and interesting. You've got some new problems that you need to address, and you've discovered you have new friends to help you address them. The conversations were recorded for the purposes of us being able to make sure we don't miss anything. We write it all up and we feed it back into the forward things. The main talks, particularly for all the details and going and checking on things, will be on the SCI website, YouTube channel sometime next week. So thank you for that. Just to plug from SCI. It's a really great organization. Please join if you're not already joining. If you're an SME, you can join as well. Actually, some of you already are, so that's okay. And there are some future events coming up. Before this, on the 29th of September, Ottiline Lacer, who is the head of UKRI, is giving a talk, and having met her on a number of occasions, she's incredibly bright and razor sharp with her analysis. So I'm quite looking forward to that talk, and that's about the wider UKRI thing. There's then the a bunch of chemistry things. The how to start a chemistry business is going to be interesting. That's actually using a number of people. In fact, I think somebody from Anaphyte is talking on that, if I remember, because we have someone from Anaphyte in the room today. Then there's a one in middle of October on photochemistry and electrochemistry, which is all about tailored chemistry. We can go into the logic of the difference between directed chemistry and bulk chemistry. And then finally in November, there's one on artificial intelligence and machine learning in how you design formulae, which is when you mix up lots of chemicals and things like that. So that's all good, clean stuff, and worth reading if you want to be a chemist. So thank you for taking part. If you want anything from us, please contact us. You can contact me. I'm pretty certain that any of the Faraday people will return emails and things like that. But thank you very much for coming, and I wish you a nice rest of the day. Where I am, it's stopped raining, but there's no blue sky yet. So there you go. Thank you very much, and I'll see you at the next one, which will probably be early December. Okay, take care. Bye.